NASA lays plans to visit the Sun. Presented by Science at NASA. June 10, 2008. For more than 400 years, astronomers have studied the Sun from afar. Now, NASA has decided to go there. We are going to visit a living, breathing star for the first time, says program scientist Lika Guhathakurta of NASA headquarters. This is an unexplored region of the solar system, and the possibilities for discovery are off the charts. The name of the mission is Solar Probe Plus. It's a heat-resistant spacecraft designed to plunge deep into the Sun's atmosphere, where it can sample solar wind and magnetism firsthand. Launch could happen as early as 2015. By the time the mission ends 7 years later, planners believe Solar Probe Plus will solve two great mysteries of astrophysics and make many new discoveries along the way. The probe is still in its early design phase, called Pre-Phase A at NASA headquarters, says Guhathakurta. We have a lot of work to do, she says, but it's very exciting. Johns Hopkins Applied Physics Lab, or APL, will design and build the spacecraft for NASA. APL already has experience sending probes toward the Sun. APL's Messenger spacecraft completed its first flyby of the planet Mercury in January 2008, and many of the same heat-resistant technologies will fortify Solar Probe Plus. At closest approach, Solar Probe Plus will be 7 million kilometers, or 9 solar radii, from the Sun. There, the spacecraft's carbon composite heat shield must withstand temperatures greater than 1400 degrees Celsius and survive blasts of radiation at levels not experienced by any previous spacecraft. Naturally, the probe is solar-powered. It will get its electricity from liquid-cooled solar panels that can retract behind the heat shield when sunlight becomes too intense. From these near distances, the Sun will appear 23 times wider than it does in the skies of Earth. The two mysteries prompting this mission are the high temperature of the Sun's corona and the puzzling acceleration of the solar wind. Mystery number 1, the corona. If you stuck a thermometer in the surface of the Sun, it would read about 6,000 degrees Celsius. Intuition says the temperature should drop as you back away. Instead, it rises. The Sun's outer atmosphere, the corona, registers more than 1,000,000 degrees Celsius, hundreds of times hotter than the star below it. This high temperature remains a mystery more than 60 years after it was first measured. Mystery number 2, the solar wind. The Sun spews a hot million-mile-per-hour wind of charged particles throughout the solar system. Planets, comets, asteroids, they all feel it. Curiously, there is no organized wind close to the Sun's surface, yet out among the planets there blows a veritable gale. Somewhere in between, some unknown agent gives the solar wind its great velocity. The question is, what? To solve these mysteries, Solar Probe Plus will actually enter the corona, says Guhathakurta. That's where the action is. The payload consists mainly of instruments designed to sense the environment right around the spacecraft. For example, a magnetometer, a plasma wave sensor, a dust detector, electron and ion analyzers, and so forth. In-situ measurements will tell us what we need to know to unravel the physics of coronal heating and solar wind acceleration, she explains. Solar Probe Plus's lone remote sensing instrument is the Hemispheric Imager. The HI for short is a telescope that will make three-dimensional images of the Sun's corona, similar to medical CAT scans. The technique, called coronal tomography, is a fundamentally new approach to solar imaging and is only possible because the photography is performed from a moving platform close to the Sun, flying through coronal clouds and streamers and imaging them as it flies by and through them. With a likely launch in May 2015, Solar Probe Plus will begin its prime mission near the end of Solar Cycle 24 and finish near the predicted maximum of Solar Cycle 25 in 2022. This would allow the spacecraft to sample the corona and solar wind at many different phases of the solar cycle. It also guarantees that Solar Probe Plus will experience a good number of solar storms near the end of its mission. While perilous, this is according to plan. Researchers suspect that many of the most dangerous particles produced by solar storms are energized in the corona, just where Solar Probe Plus will be. Solar Probe Plus may be able to observe the process in action and show researchers how to forecast solar energetic particle events that threaten the health and safety of astronauts. Solar Probe's repeated plunges into the corona will be accomplished by means of Venus flybys. The spacecraft will swing by Venus 7 times in 6 years to bend the probe's trajectory deeper and deeper into the Sun's atmosphere. Bonus: although Venus is not a primary target of the mission, astronomers may learn new things about the planet when the heavily instrumented probe swings by. Solar Probe Plus is an extraordinary mission of exploration, discovery, and deep understanding, says Guhathakurta. We can't wait to get started. This story was written and read by Tony Phillips and presented by Science at NASA. To find more Science at NASA stories on the Internet, please visit science.nasa.gov.